Hello everyone, welcome back to Learn with Shireen Kazi, and today we are doing physics motion. In last lecture we had an introductory lesson on motion. Today we are going to be discussing about uniform and non-uniform motion. Last lecture we had discussed about distance and displacement and vector quantity and scalar quantity. Now without further ado, let's get started. First, we have when a body travels equal distance in equal interval of time, then the motion is said to be uniform motion. What is meant? We can understand this with the help of a distance time graph. Just plot some lines. Okay, now equal distance in equal interval of time, meaning the speed will remain constant. Okay, for example, we have this we have this distance and we have this distance, both are equal, and we have this interval of time and this interval of time. The distance traveled here is the same amount, and also the distance traveled here is also the same amount. This slope is the speed, and the speed is a straight slope, meaning the speed is constant. The speed is constant. Thus, the motion is uniform motion. The motion is uniform motion. Next, we have the opposite of this, non-uniform motion. What is non-uniform motion? Let's understand. This bottom line is the distance, and the line perpendicular to the distance line is the timeline. For example, the graph of non-uniform motion goes like this. Okay, we have this and we have this. Is the distance or time taken equal? No, right? Thus, this is non-uniform motion. It can be unequal distances in equal intervals or equal distances in unequal intervals of time. Both will be non-uniform motion. Next, we have a topic that is accelerated motion. Now, let me tell you what accelerated motion looks like. Accelerated motion looks like this. No, sorry, my mistake. Acceleration motion looks like this, where with time the motion of a body increases, or the speed of a body increases with time. And what about deaccelerated motion? Deaccelerated motion, or also called retarded motion, is the complete opposite. This is the speed and it is decreasing. This is deaccelerated motion. Both acceleration and deacceleration are examples of non-uniform motion. Moving on, we have a lot of information. This is about speed. Don't mug it up, understand it. I also want to tell you something, that the concepts of physics are easy to understand but hard to apply. So the concepts should be really clear and you should learn how to apply them. So we have the measurement of distance traveled by a body per unit time is called speed. Now, didn't understand? Let me explain it again. You know, speed v is equal to distance traveled upon time taken is equal to st. SI unit is equal to meter per second. Now don't mug it up. First we have the measurement of distance traveled by a body per unit time is called speed. For example, we have x distance and we have y time. Speed is the measurement of a distance. For example, speed is equal to x by y. And what is the formula of speed? Distance traveled upon time taken is equal to s by t, or s is equal to d by t. What is the SI unit? The SI unit of distance is meter. Let me clear this up. Okay. The SI unit of distance is meter. The SI unit of distance is meter, and the SI unit of time is second. So the SI unit of speed will be distance upon time. That would be meter per second. Okay, I hope you understood that. Next we have a constant speed. We have just studied about this. If a body is executing uniform motion, then there will be a constant speed or uniform motion. If a body is traveling with non-uniform motion, then the speed will not remain uniform but have different values throughout the motion of such body. Don't mug it up. We have just about learnt about uniform and non-uniform motion. In uniform motion, speed is constant, or let us k. But in non-uniform motion, the speed is variating. Okay. For non-uniform motion, average speed will be described by one single value. For example, we have in this distance, x distance, it travels 6 km per hour, and in this the same distance, the distance is same, it traveled 8 kilometers per hour. That, for example, it traveled for 2 hours, so it traveled 6 plus 8 kilometers, and that will be divided by total time taken, that is 2. That would be 7. So the average speed of the it would be 7 kilometers per hour. I hope you understood that well. Next, I have another example. For example, a body is traveling 4 units. A body travel for 2 hours at the speed of 40 kilometers per hour, and then 4 units again at the speed of 50 kilometers per hour. What would be the average speed? That would be 2 hours, 2 hours. Total distance traveled is equal to 40 into 2 plus 50 into 2 upon 4. Simplifying this, we get 2 into 40 plus 50 upon 4. 2 ones are 2 twos are is equal to 45 kilometers per hour. I hope you understood that well and how to apply the concept. Next, we have the conversion of speed. If we have to change from kilometer per hour to meter per second, what will we do? 1 kilometer is equal to 1000 meters. Okay, and 1 hour is equal to कितना? 60 minutes, and that 60 minutes times 60 seconds. Just cancel the zeros, and that would become 10 by 36 is equal to 5 by 18 meters per second. So 1 kilometer per hour is equal to 5 by 18. meters per second. Okay. Now talking about velocity. Okay. Speed is a scalar quantity and velocity is a vector quantity. Speed had relation with distance, but this velocity has relation with displacement. Okay. The total displacement upon time. Okay. But let's say, how do we calculate displacement? You have a question. How do we calculate displacement? Well, we will learn about that later, but let us say that we have a displacement of 5 meters, and the displacement will take 9 seconds to cover. So the velocity will be 5 by 9 meters per second. Velocity is a vector quantity. Its value changes when either its magnitude, we know about it, or direction changes. For non-uniform motion in a given line, average velocity will be calculated in the same way as done in average speed. For example, we have a displacement of 6 meters and a displacement of 8 meters, and the total time is 2 hours, so that would be 14 by 2 is equal to 7. So the displacement will be 7 meter, so the velocity, average velocity, would be 7 meter per hour. Okay, we have another formula. For uniformly changing velocity, the average velocity can be calculated as follows. Average velocity, don't be confused when this comes in the exam. This just means average velocity. Average velocity is equal to initial velocity plus final velocity upon 2. That is, for example, we have no. Okay, so average velocity is equal to initial velocity plus final velocity upon 2. Okay, next, SI unit of velocity is meter second, ms to the negative 1. Then we have velocity is equal to displacement upon time. We just studied it can be positive, it can be negative, or it can be 0. Since displacement can be positive, it can be negative, and it can also be 0. Okay, and I hope you understood that well. If you didn't understand, please leave your feedback in the comments, and if you did understand, please like, share, and subscribe. See you next time. Bye bye.